Hello friends, welcome. Today, let's begin by understanding the relationship between artificial intelligence, machine learning, neural networks, and deep learning. Think of this as a set of nested circles, where each one is a subset of the larger one. At the outermost level, we have artificial intelligence or AI. This includes any computer or machine that mimics human intelligence to perform tasks like decision making, problem solving, or recognizing patterns. Within artificial intelligence, we have machine learning or ML. This is how machines learn from data instead of being explicitly programmed. It allows the systems to improve over time based on experience. A smaller subset of machine learning is neural networks. These are algorithms modeled after the structure of the human brain, made up of interconnected layers of nodes. And finally, at the core, we have deep learning, a more advanced form of neural networks with many hidden layers. That's why it's called deep. It gives deeper into the data to find complex patterns. So deep learning is a subset of neural networks, which is a subset of machine learning, and which itself is a subset of artificial intelligence. Now let's understand. So what exactly is artificial intelligence? AI refers to any machine or computer program that mimics human intelligence. This could be as simple as a robot vacuum cleaner that learns to navigate your room, or a voice assistant like Siri or Alexa that understands and responds to your commands, or even a smart traffic light that changes timing based on the flow of vehicles. The key idea is the machine is making decisions or taking actions that seem intelligent. That's why artificial intelligence is the big umbrella term. Everything else, like machine learning, neural networks, and deep learning, fits inside this broad category. Let's see some very everyday examples that you have probably seen. Also, now let's look at some more everyday examples you've probably seen. For example, the email spam filters that detect and block unwanted messages, or even the recommendation engines like the ones on Netflix or YouTube that suggest what you might like to watch next based on your behavior. Even the face unlock on your phone, that's AI recognizing and verifying your identity. The point is, whenever a machine does something intelligent or decision based without being manually told every step, it's using artificial intelligence. That's why we say AI is the big umbrella. Inside it, we have more specific techniques like ML, neural networks, and deep learning, which we'll explore next. Now let's talk about machine learning or ML, a powerful subset of artificial intelligence. Machine learning is a method in artificial intelligence where machines learn from data without being explicitly programmed. That means instead of writing a set of fixed rules, we are giving the machine a lot of data and it learns patterns and builds its own rules to make predictions or decisions. For example, a spam filter learns from thousands of emails what counts as spam and what doesn't. An e-commerce site like Amazon uses machine learning to recommend products based on what you and others have viewed or purchased. In healthcare, machine learning helps predict diseases by analyzing patient history and medical data. Even your camera's portrait mode uses machine learning to detect and focus on faces. Now, some common machine learning techniques include, for example, like linear regression, which is great for predicting continuous values like house prices, or decision trees, which is for rule-based decision making. Then we have support vector machines. They are useful in classification problems like email spam detection, and even the k nearest neighbors, which classifies data points based on similarity. So the key idea is in machine learning, we don't tell the machine how to do the task. We give it data and it figures out the logic on its own. Next, let's explore neural networks, which are a special type of machine learning algorithm, and they are inspired by how the human brain works. Just like our brain is made up of neurons, a neural network is made up of layers of artificial neurons or nodes. These layers take in raw input data, process it step by step, and produce an output, like a prediction or a classification. For example, if you give it an image of a cat, the network will process the pixels through multiple layers and finally say, yes, this is a cat. Early neural networks had only one or two hidden layers between the input and output, so they could handle simple tasks like recognizing basic handwritten digits or basic classification problems. But they struggled with more complex tasks like speech recognition or image generation. That's why we say neural networks are the building blocks of deep learning. Now, when we add more layers and depth, they become powerful deep learning models. In short, neural networks mimic brain like learning and are key to solving more advanced AI problems. Now, let's look at deep learning, which is a more advanced form of neural networks, and it's where things start to get really powerful. Deep learning uses many layers of neurons, that's why it's called deep. These deep architectures allow the model to learn more abstract and complex patterns from data. What makes deep learning unique is that it can automatically learn the right features from raw data. No need for manual feature selection. The model figures it out on its own. This makes it perfect for solving very complex tasks like image recognition, that is, identifying objects, faces, or scenes in a photo. Even speech synthesis and recognition, like converting voice to text and vice versa. And natural language understanding, that is, making sense of human language. In fact, large language models like ChatGPT, the one you're hearing right now, are built using deep learning. So whenever you use a chatbot, you use a voice assistant, or even auto captioning on YouTube, that's deep learning working behind the scenes. Deep learning takes the neural networks to the next level, enabling machines to understand, see, hear, and even create. Now, here is a visual representation of what we have learned. Imagine artificial intelligence is the whole universe. Machine learning is a galaxy. Neural networks are a solar system. And deep learning is a powerful planet inside it. So, this is a great analogy. Let's now compare machine learning and deep learning side by side across key features so you understand when to use which technique. Let's start with machine learning. Machine learning is a subset of AI that learns from data using statistical methods. Deep learning is a further subset of machine learning that uses multi-layered neural networks to learn from large data sets. Based on structure, machine learning uses algorithms like decision trees, support vector machines, and random forests, whereas deep learning relies on artificial neural networks, often with many hidden layers, making the architecture deeper and more complex. Next, based on feature engineering. In machine learning, humans manually select important features from data like age or income for predicting loan approval. But in deep learning, the model automatically learns the features by itself, which reduces the need for manual effort. Now, based on data requirements, machine learning works well with small to medium data sets. Deep learning, however, requires massive amounts of data to perform well. Next is hardware dependency. Machine learning models can run efficiently on CPUs, but deep learning models are more complex and often need GPU or TPUs to process data faster. Now, based on training time, machine learning training is usually faster because the models are less complex, whereas deep learning takes longer to train due to the depth and number of parameters involved. Now, let's look at interpretability. Machine learning models are generally easier to interpret. We can often understand how decisions were made. But in the case of deep learning, models are often considered a black box, making them harder to explain. Now, let's look at some of the use cases. Machine learning is great for tasks like spam detection, fraud detection, credit scoring, and deep learning shines in more complex tasks like self driving cars, facial recognition, language translation, and voice assistance. Now let's look at algorithms and models. Machine learning uses classic models like logistic regression, naive Bayes, KNN, SVM. And deep learning uses advanced models like CNNs, RNNs, LSTMs, and transformers, which power systems like ChatGPT. Based on performance, machine learning performs well on similar problems with limited data, whereas deep learning is ideal for complex problems and excels with big data. Scalability: machine learning may struggle to scale in very high dimensional spaces, but deep learning is highly scalable and improves as you add more data and computer power. So, in short, my friends, choose machine learning for smaller, interpretable tasks and deep learning when you need more powerful performance on complex, data rich problems. Now you know how AI, ML, neural networks, and deep learning fit together, like layers of the same intelligent system. So keep exploring because understanding these foundations is the first step to mastering the future.